Electricity always wants to move from a place where there is more of it to a place where there is less. Like water flowing downhill, it finds the easiest path it can. If there is an open path, it rushes through it, fast and free. But in the real world, there is no such thing as perfect path. No wire or no material let it flow without a fight. When electricity moves through a wire, tiny particles called electrons start drifting forward. Not like bullet, not like river. They move slowly, and on their way they keep bumping into the metal itself. Inside the wire there are atoms, billions and billions of them. They sit in a fixed pattern, but they are never still. Even at room temperature they vibrate all the time. So the electrons keep hitting these vibrating atoms. They scatter, they lose some of their push. And this simple fight between moving electrons and vibrating atom is what we call resistance. Resistance is just the opposition that a material gives to the flow of electric current. And something else happens. Each collision steals a bit of energy from the electrons. That energy does not disappear, it becomes heat. This is called Joule heating. It is the reason a bulb filament glows. It is why wires feel warm when a lot of current flows through them. Not all wires resist in the same way. There are 4 main things that decides how much resistance there will be. First, the length. The longer the path, the more chances the electrons have to bump and scatter. So long wires have more resistance. Second, the cross section or the thickness. A thin wire gives less space for electrons to move. It's like a narrow road. More bumps, more resistance. A thick wire let them pass more easily. Third, the material. Copper and silver let electrons flow easily. Nichrome, carbon and other resistive materials slow them down a lot more. And fourth, the temperature. As a wire gets hotter, the atoms inside it vibrates even more. This makes it even hard for electrons to pass. So the resistance increases with the temperature. Now that we know what resistance is, there is one simple rule that tells us how current, voltage and resistance are connected. It's called Ohm's law. It says voltage equals current multiplied by resistance. Or in short, V equal to I into R. Think of it like a fan blowing smoke through a vent. Voltage is how fast the fan spins, how hard it pushes the air. Current is the amount of smoke that actually passes through. And the resistance is the vent, wide and open or narrow and blocked. Spin the fan faster and more smoke flows. Make the vent thinner and the flow slows down. This one simple formula helps engineers predict what will happen in any circuit. If you know any 2, voltage, current or resistance, you can always find a third. Now, why do we need resistor? If electricity could rush uncontrolled, delicate parts like LED, sensor or microchips would burn out instantly. When we add a resistor in a circuit, it acts like a gentle brake. It slows the flow of current to a safe level. This protects the parts. Resistors also help divide voltage into smaller and safer amounts. This is important when a circuit needs different voltage level at different points. And they help control signals so that timing in circuit stays perfect. They are small but very powerful tools for shaping electricity. You can see this in a very simple example. Connect an LED straight to a battery and in an instant it burns out. But add a resistor and suddenly the LED glows perfectly. Resistors don't move or make sound, but inside, the electrons are always in motion, bumping into each other. This creates a tiny random electrical noise. It's called Johnson-Nyquist noise. It's so small we never notice it, but a very sensitive oscilloscope can. Resistance may sound like a small thing, but it is one of the most important ideas in all of electronics. It is the invisible force that slows down electricity and let us shape it. Without resistance, there would be no way to control electricity. And without resistors, there would be no modern electronics. This is why resistors matter. They keep everything safe, balanced and under control.